Hi students and welcome to today's lesson. I'm Mr. Hunter. Today we will explore the question, what happens to matter during heating and cooling? Are you ready? Grab your pencil and your science journal and let's get started. Who wants ice cream? I do. Oh no, my ice cream cone. What is happening? Did you say the ice cream is melting? That's right. The ice cream is melting all over the table. You know, the ice cream reminds me of what we learned about different types of matter. Remember, different types of matter have different properties. What types of matter did you observe in the video clip? Well, the ice cream started as a solid, right? But then the ice cream became a liquid. What properties helped you decide that the solid ice cream became a liquid? At the beginning of the video clip, the ice cream was shaped like a ball, right? But as the ice cream melted, it spread out over the table. The ice cream's shape changed. That property helped me decide that the solid ice cream had changed to liquid ice cream. What do you think caused the ice cream to change from a solid to a liquid? I think ice cream turns to liquid when ice cream gets warm. Do you agree? Yes, heating caused the ice cream to change from solid to liquid. Changes in temperature can cause changes to matter. We will continue to explore this topic today as we investigate the question, what happens to matter during heating and cooling? What can we use to measure how hot or cold something is? We need a thermometer, right? A thermometer is a tool used to measure temperature. Let's explore how to read a thermometer together. Look closely at the numbers and tick marks on the side of the thermometer with this label. A thermometer is a little bit like a ruler. Each tick mark on a thermometer represents an amount or quantity, and the space between each tick mark represents an equal unit. What do you think the value of each tick mark on this thermometer is? Shout out your answer. I see that the large numbers on the thermometer go up by tens. Let's look at the smaller tick marks between 20 and 30. I see 4 tick marks. Can we count by ones to get from 20 to 30? Let's try. We will start at the tick mark for 20. 20, 21, 22, 23, 24. No, that didn't work. There aren't enough tick marks. Can we count by twos? Let's try. We will start at the tick mark for 20 again. 20, 22, 24, 26, 28, 30. Yes, counting by twos worked. So we know that each smaller tick mark shows a change of 2 units. Great work. Now, let's look at this symbol and letter. The symbol stands for degree, and the letter C stands for Celsius. A degree Celsius is a unit used to measure temperature. Scientists all around the world measure temperature in degrees Celsius. When we measure temperature, we will also use the Celsius scale. So we will always use the unit degrees Celsius. Be sure to always record the unit when you record a temperature. You should include the degree symbol and the letter C or the words degrees Celsius. Let's use what we practiced to read the temperature on this thermometer. What is the temperature? The temperature is 24 degrees Celsius. Let's practice measuring temperature again. Look at the red line on the thermometer. Which tick mark most closely lines up with the top of the red line? Point to the tick mark. Did you point to this tick mark? Great! What temperature does this tick mark represent? Did you say 26 degrees Celsius? That's right. The temperature of the room I am in right now is 26 degrees Celsius. We will continue to measure temperature as we explore how changes in temperature can cause changes to matter. Now, let's measure the temperature of these ice cubes. The thermometer shows the temperature of the ice cubes in the beaker. What is the temperature of the ice according to the thermometer? Shout out your answer. Wow, the ice is 0 degrees Celsius. How does the temperature of my room compare with the temperature of the ice cubes? Well, the room is 26 degrees Celsius, but the ice is 0 degrees Celsius. So the temperature of the ice cubes is lower than the temperature of the room. That means the ice cubes are colder than the room. What else do you notice about the properties of the ice cubes? I notice that the ice cubes are solid. How can you describe their shape? I think the ice cubes are box-shaped. Soon we will heat up these ice cubes and make more observations. Let's record what we have noticed about the ice cubes so far in this chart. We can call this column Properties Before Heating. Have you ever seen this object before? This object is a hot plate. When I turn on the hot plate, this metal surface will get very hot. I have placed a beaker filled with ice cubes on the hot plate. What will happen to the ice cubes when we turn on the hot plate? Well, the temperature of the ice cubes will go up because the hot plate will heat the ice. Do you think the ice cubes will melt? I think so. Let's find out. What do you notice? I notice the ice cubes getting smaller, and there's liquid in the bottom of the beaker. Wow! Now the ice cubes have completely turned into water. Let's measure the temperature of the water. What temperature is the water? I see the red line is between the tick mark for 34 degrees Celsius and 36 degrees Celsius. So the water is 35 degrees Celsius. What other properties do you observe? Do you notice that the water is liquid? I noticed that too. What shape is the water? The water takes the shape of the beaker, right? Great work. Let's record these observations in our chart. We can call this column Properties After Heating. Which properties of the ice cubes changed after heating? The temperature changed. The temperature of the ice cubes was higher after we heated the beaker. The ice cubes also changed from solid to liquid. They melted. Remember, melting occurs when matter changes from a solid to a liquid. Did any other properties of the ice cubes change? What about the shape? Yes, the shape changed too. The shape of the ice cubes changed from box-shaped to round like the beaker. Let's summarize what we learned today in a cause and effect chart. What caused the ice cubes to change? Well, the ice cubes changed when we heated them. So let's write heating under cause. What was the effect of heating the ice cubes? The effect was melting. The ice cubes changed from solid to liquid. At the beginning of the lesson, we recorded the temperature of my room. How does the temperature of the water after heating compare with the temperature of my room? My room is 26 degrees Celsius. The water is 35 degrees Celsius. So the water temperature is hotter than the room temperature. Okay, now I want you to make a prediction. What do you predict will happen to the water when it is left in a room overnight? Your task at the end of this lesson will be to make this prediction. Do you think the properties of water will change? Or do you think the properties will stay the same? In our next lesson, we will observe the water to decide whether its properties changed after we left the water in a room overnight. Let's review your task for today. Respond to the question about the properties of the water left overnight in a room.